Hi everyone, we are going to discuss about half adder. So what do you mean by half adder? The half adder is a combination circuit. So this is a combinational circuit which is used to add two single bit numbers. So here the addition of two single bit numbers will happen. Okay. So this is a combination circuit, and here the combination circuit is nothing but half adder. It is used to add two single bit numbers, and let the two numbers be A and B. Both the numbers are single bit numbers. And what do you mean by combination circuit? Here the output at any instant will depend only on the present input. The output will depend only on the present input. So it's a combination circuit which is used to add two single bit numbers, and this combination circuit is known as the output will be depending only on the present input signal. And here we don't have any memory elements to save the previous inputs or something else. And here one of the main disadvantage of this half adder is it doesn't have any provision to add the carries which are generated from the lower order addition. So while adding the lower order bits, if any carry is generated, we don't have any provision to add such carries in half adder. So if we add two numbers, what will be the output? One will be a sum and another one will be a carry. The sum will be generated and carry will be generated. So let's discuss the truth table of this half adder. Let it be input and here it is output. So what are the inputs? A and B. The output will be sum and carry. So both are single bit numbers. We know the combination 0 0 0 1 1 0 1 1. If we add 0 and 0, the sum will be 0, carry also will be 0. So 0 plus 1, sum is 1, carry is 0, again sum is 1, carry is 0. If we add 1 and 1 in binary addition, what you will get? 1 plus 1 is 1 0. So 0 will be the sum and 1 will be the carry. Okay. So sum is 0 and carry is 1. Now we have to find out the output equations for this sum and carry, and this can be determined by using K-maps. Okay. We have to draw the K-map for the sum and carry of this. Okay. This is for sum. So the input bits are A and B. You know that it's 0 1 0 and 1. So for 0 0 it's 0. For 0 1 it is when 0 1 you have the sum as 1. Similarly 1 and 0 you have sum as 1. So the equation will be, so for this combination it is A B bar plus, for this combination now it's A bar B. Here B is 1, so B. So what is this A B bar plus A bar B? That is A XOR B. That is sum. Now draw the K-map for the carry. Inputs will be A and B. So this is 0 1 0 1 So this is carry. So in carry, we'll have the output when the inputs are 1 and 1. So input 1 and 1, we have the output as 1. So what is the equation for this? So here it is A and here it is B. So A, B. Right? So the equations for the half adder output is, the sum is A XOR B and carry is A, B. Hope you are clear about this. Now we have to draw the logic diagram. So first we'll draw for the sum. Two inputs A, B, and for sum the output is A XOR B. So draw an XOR gate. This is sum, that is A XOR B. And for carry it is A and B. So we'll take A and B. We'll use an AND gate. So the carry is A, B. So this is all about half adder circuit. Now we have to discuss about full adder circuit. We will be watching the next series. Before that, why we are going for the full adder is, already I told you that in half adder we don't have any provision to add the carries which have been generated from the lower adder addition. So in order to rectify this problem, we will be going for full adder circuit. Kindly watch this, kindly support, keep sharing. Thanks for watching. Kindly subscribe. Thank you so much.